Welcome back, everyone, to 6.3. Today we're going to talk about the final way we solve systems of equations, and that is the elimination method. The premise of the elimination method is if we have two or more equations and we want to find the solution or where they intersect, then we can manipulate the equations together in a way that reveals information about them. So we can add, subtract, multiply. We can do all sorts of wonderful things with these equations in order to solve for one of the missing variables. It seems complicated at first, but once you understand the premise and the basics of elimination, I assure you that you will find it neat and organized. So one of the first things you'll notice is we have a system here, and if we were using the substitution method, you would recognize that, oh boy, we have a lot of work to do. The x and the y are not by themselves, and so we'd have to subtract and add and all that stuff. And you'll recognize that both these are in standard form. So standard form is not ideal for substitution, but it's not impossible, okay? You can always use substitution. That is a guarantee. However, it's not always the most effective or efficient way to solve a system. So that's why we need to learn both substitution and elimination. So these are both in standard form, and you'll realize that equations should be in standard form if we're going to use elimination. That makes it much easier for these processes. So it's a four-step process, and step one is determine if here we're going to add x or y variables match or are opposites. Okay, and what does that mean? That means that we need to see if the coefficients are opposites or are able to match. So if we're looking here, what do I mean by that? Look here with the y's. The y's have a 3 and a 5 in front for their coefficients. Now, it's not impossible, but that's difficult to get those two to match. So that's not ideal, okay? So let's take a look at the x's. Maybe the x's will be better. So we have a 2 and a negative 2. One thing you'll notice is they already are opposites, and that is a good thing. We want them to be opposites. That makes it a lot easier for us. So we need to determine if their x or y variables are if they match or are opposites, okay? And ideally, we want them to be, whoops, I thought I had my highlighter. We want them to be opposites. Step 2, multiply the equation so that the x or y coefficients are opposites. Now, for some of you more advanced individuals, you can make it so that they match and then subtract. I am strictly teaching to a more general audience who appreciate getting it into the same form each time, and it kind of makes it a little bit more simple to do if they realize they just need to make them opposites each time. I find that getting the coefficients to match, a lot of students make mistakes in subtraction, whereas if they are opposites, they wouldn't have that problem, okay? So just keep that in mind. If you're wondering, oh, why isn't he teaching the matching method? That's because I find that fewer mistakes are made when you make them opposites, okay? So if we look at our example here, we already see that they are opposites, so we're fine. We don't need to do anything to the equation, okay? So actually, let me go ahead, and I'm going to copy and paste this equation. You may not be able to copy and paste, but you can certainly write it. It's good for you. Now, you'll notice that we already determined that these are opposites. That's great. Okay, so we're doing well. Now, let's say they weren't. Let's say it was 2x plus 3y equals 7, and it was 2x plus 5y equals 1. What is step 2 talking about? Step 2 is saying that if these were the same, what we can do is we can change one of the equations so that it becomes opposites. Now, we already determined, it's going to be easy to get our x's to be opposites. Why? Because they already both have a 2 in front. The y's have a 3 and a 5. It's going to be a little tricky, okay? We're going to have to do a little bit more manipulation. But because these are almost opposites, we see that if we multiply both sides of the second equation by -1, what happens? Well, we're going to distribute that -1 to all three terms. We get -2x minus 5y equals -1. So So I'm going to go ahead and rewrite the original. So we had 2x plus 3y equals 7. Are these opposite coefficients now? Now they are. Now you're saying, whoa, 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 back up. These are two different equations. Although they look like they're two different equations, they are equivalent because they have the same value. What we multiplied by, we did to both sides of the equal sign, so we're good. It looks different, but it is the same equation, and now it makes it easier for us to use elimination. So that's just something to keep in mind here. Now, for this example, we are already set. They're already opposites. We don't have to multiply either equation by anything, so we're good to go, okay? Step 3, add equations to eliminate variable and solve for other. So if we have opposite coefficients, we are going to add equations. Okay, now for some of you that like to use the match method, and I'm not going to explain it in this video because I don't want to confuse anybody, but you are going to subtract. Okay, but I like to make it so it's opposites. I think it's much easier for everyone to manipulate the equations, make them opposites, and then always add. Fewer mistakes are made. Okay, so we recognize that these opposites, so what we're going to do is we are going to add these equations. Okay, and this is where things get interesting. Why do we add these two equations together? Well, take a look. What happens when we add a negative 2x with a positive 2x? Now, one of the things I need to mention, as you add equations, what you're doing is you're simply combining like terms on the left side of the equal sign. Okay, so we're going to add anything that's a like term on the left side, and we're going to add anything that's a like term on the right side. Okay, so look here, the only thing that we have like terms for the left side are the 2x and the negative 2x. And when we add 2x and a negative 2x, what happens? We get 0x. I'm going to come back to that in a second. Now we have 3y and 5y. Those are like terms. They both have y. So we are going to write 8y. On the right side of the equal sign, 7 plus 1, that's 8. Now, how do we know we did this right? Well, it's called the elimination method for a reason. 0 times x is just 0, so we don't even need to write it. It was eliminated, and that's the whole point. That's why it's called elimination. Okay, so you know those movies where you have the title of the movie, Onward's a great example, just watch that, great movie. But the name of the movie finally appears later on. Well, it's just like when he's driving his car and he puts it into Onward. And then you say, oh, that's why the movie's called Onward. Exactly why this is called elimination. You're going through the problem and you eliminate the x's, like, oh, that's why it's called elimination. Okay, I digress. So we divide both sides by 8. We had 8y equals 8. Divide both sides by 8. We get y equals 1. Now that we have y equals a number, okay, y equals a number, this is just like our final step with substitution. Remember when we did that? Our step 3, plug in known value. Well, we have y equals a number. We have y equals 8. We're going to plug that back into either equation. So I have y equals, oh, sorry, not y equals 8. I have y equals 1. So now I can plug that into either equation. Now, for this, I can use some strategy. Okay, but to me, it looks like I don't want to multiply too big of numbers, so I'm going to choose 1. Is there a huge difference? No, there's not a huge difference. And some problems there will be, but in this particular case, there's not a huge difference. But sometimes you just have to go for your preference, okay? So I plugged in, instead of writing 2x plus 3y equals 7, I wrote 2x plus 3 times 1, because that's the value of y, and I substituted it in, equals 7. Now I have an equation with only one variable, and I can solve for my missing x. So I have 2x plus 3 equals 7. I subtract both sides by 3. I get 2x equals 4. Divide by 2 to get x by itself, doing the opposite operation of multiplying, and I get x equals 2. So my final answer, 2, 1 is the solution to the system using the elimination method. Hope you enjoyed this video.